Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions. This is part 7 of the chapter and it is belonging to class 12 of CBSE. So let us start. Now today we will see that Raoult's law is a special case of Henry's law. Means we will see how Raoult's law is a special case of Henry's law. Now, according to Raoult's law, the vapor pressure of a volatile component in a given solution is given by the equation P1 is equal to x1 P1 naught, where P1 naught is the vapor pressure of the pure component 1, means when the component is in pure state, it is not present in a solution at that time, and x1 is the mole fraction of that component. x1 is the mole fraction of that component. Now, in solution of a gas in liquid, one of the components is volatile and exists as a gas. Then its solubility is given by Henry's law. Now, in this case, the equation is P is equal to KHX. Here, KH is Henry's law constant. Now, if we compare both the equations, we get the partial pressure of the volatile component or gas is directly proportional to its mole fraction. In both the cases, we see the term X, that is mole fraction, is present. This term is there. So, the partial pressure of the volatile component or the gas is directly proportional to its mole fraction in solution. Only the difference is that the proportionality constant Kh, which we find here, differs from P1 naught. So here Raoult's law becomes a special case of Henry's law, where Kh becomes equal to P1 naught. Kh becomes equal to P1 naught. Next, vapor pressure of solutions of solids in liquids. Now let us take the case of a solution of solid dissolved in liquid. We find that some physical properties are quite different than the pure solvents. For example, solution of sodium chloride or glucose or cane sugar in water, and at the same time we can also take the case of sulfur dissolved in carbon disulfide. In these cases, some physical properties of the solutions are different from those of their pure solvents, like vapor pressure. Okay. Now, in a pure liquid, what happens? The entire surface is occupied by the molecules of the liquid. If we take pure liquid in a container, this is the container, in this there is pure liquid. So here all the molecules on the surface are of that component only, of the same component. That is a pure solvent. All the molecules, entire surface is occupied by the molecules of the liquid. But in this, if we add a non-volatile solute to the solvent, we get a solution. Now the vapor pressure of the solution is only from the solvent alone, because it is a non-volatile solute. So the vapor pressure of the solution at a given temperature is found to be lower than the vapor pressure of the pure solvent at the same temperature. Now when we are adding a solute, what happens? You see, this will be the situation. This is the solution in which some of the molecules will be of the pure solvent, but at the same time some molecules will belong to the non-volatile solute, which I am marking with a green color. So these are non-volatile. So there is a good mixture. There is molecules of the pure solvent as well as that of the non-volatile solute. But here we will find that the vapor pressure of the solution is lower than the vapor pressure of the pure solvent, because vapor pressure of the solution is solely from the solvent alone. So the fraction of the surface covered by the solvent molecules is getting reduced here. We can find here, because some of the molecules of the non-volatile solute is also present. In solution, the fraction of surface covered by the solvent molecules gets reduced. And the decrease in vapor pressure, how much decrease is there of the solvent, means the decrease in vapor pressure of the solvent depends on quantity of non-volatile solute. So the quantity of the solute will decide the decrease in vapor pressure of the solvent. Now Raoult's law states that for any solution, The partial vapor pressure of each volatile component in the solution is directly proportional to its mole fraction. We have to be careful, it is a volatile component in the solution. So the partial vapor pressure of each volatile component in the solution is directly proportional to its mole fraction. Now if P1 is the vapor pressure of the solvent, X1 is the mole fraction, and P1 naught is the vapor pressure in pure state, then P1 is equal to X1 P1 naught. P1 is directly proportional to X1. P1 is directly proportional to X1. So if we remove the proportionality sign, we multiply with P1 naught. So P1 is equal to X1 P1 naught. Proportionality constant is equal to the vapor pressure of the pure solvent P1 naught in this case. Now if we plot a graph between vapor pressure and mole fraction of the solvent, plot a graph between vapor pressure and the mole fraction of the solvent, we get a linear graph. You see here in this diagram, the vapor pressure of pure solvent, as we can see here, vapor pressure in one axis and mole fraction of the solvent in another axis, we get a straight line. The graph is linear. A plot between vapor pressure and mole fraction of the solvent, plot between vapor pressure and mole fraction of the solvent is linear. We get a linear graph. Now see, we can also solve one small numerical. Mole fraction of A in vapor phase is x1, okay, and if it is in liquid mixture it is x2. Its mole fraction in liquid mixture is x2. One component is A, another component is B. Mole fraction of A in vapor phase is x1 and in liquid mixture is x2. Pa naught is vapor pressure of pure A. Pb naught is the vapor pressure of pure component B. Total vapor pressure of liquid mixture we have to find out. Now see, Pa is equal to Pa naught x2. This is for A in the liquid mixture. Pa is equal to, that is total pressure for Pa. Only for Pa when it is in liquid mixture. Pa is equal to Pa naught x2. This is for A. So mole fraction of A in the vapor will be Pa by P total. That is denoted as x1. But what is Pa? Pa is equal to Pa naught x2 by P. Pa naught x2 by P. That is x1. Now we interchange the positions of x1 and P. We get P is equal to Pa naught x2 by x1. This is P, and we were asked to find out total vapor pressure. So that is P. P is equal to Pa naught x2 by x1. I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to the channel and please share the video. Please subscribe to the channel. Thanks for watching. Thank you.